there, Rahman?
A mass of 2.65 kilograms is attached.
Oh, sorry, before you do, what's the ID number for everyone?
103.
Huh?
103.
103. Okay, 2.65 kilograms, okay.
Is attached to one end of a 1.34 meter length of string.
Uh-huh.
The other end of the string is fixed to a rigid support.
Uh-huh.
The string is fully stretched out in a horizontal direction,
Aha.
and the mass is then released so that it falls in a circular arc.
Uh-huh.
Determine the tension in the string when the mass is at its lowest position.
Here.
Yes.
So, that's interesting. I think what we'll need to do first is find the energy, the conservation of energy. So, this here will have potential energy of mg h. And this will have kinetic energy of a half v squared. And they should be the same. And this gives us the v. And what's that?
5.13.
Say again?
5.13.
5.13? 5.
Yeah.
5. Yeah? Now, we can get the tension here, because the tension minus the weight will be, well, okay, which will be bigger, the tension or the weight here? The tension will be bigger, because it's turning in a circle. In fact, there will be a net force towards the centre of the circle here, and that net force will equal T minus W. And we know F is MA. MA equals T minus W. And we know A is V squared over R equals T minus W. Now let's just recap. Do we know W? Yes.
No.
Do we know the radius? Yes. Do we know the mass? Yes. Now, do we know the V?
Yes.
Yes. So we could know easily the T, and we're done.
7.98.
What is it?
77.9.
What is it? Is it?
78.
Oh. 78.
77.98.
0.0 newtons. Okay. Okay.
Yeah.
So what caught you?
I didn't think that I would use the energy.
Ah. Yeah. That's the thing with the physics questions in the exam. Sometimes they jump a topic, or sometimes you need to combine two topics. Yeah. It was snowing this morning. I got off the train and I thought, I'm not going to cycle in that. I'll have a breakfast burger and wait until it stops. Worth it. Right, what's the next question?
Number 10.
10, okay. What ID number is that?
42.
422?
By the way,
Yeah.
12 and 16 and 6.
Exactly the same.
Yeah.
Not even a number difference.
Yeah.
Okay, I'll delete one of them then.
You have to do that one too.
I'll have to do 12 as well. Right, so I'll do, what would we say, 10 first?
Mm.
Yeah, okay, what's the ID number?
422.
422. Okay, who's this one for? Is it for you, Bello? Can you read it to me, please?
As the car travels over a small bridge, its path follows part of a vertical circle of radius of curvature 80 meters.
Okay.
The mass of the car is 1000 kg and its speed is 15 meters per second.
Okay.
It says on a sketch of this diagram, draw an arrow to show the resultant force on the car.
What did it say about the 15? Did it say the 15 was a constant?
No, just says its speed is.
Really, they should say its speed is a constant 15. Because if it's moving in a circle, its speed has to be a constant. For example, this could be moving in a circle over the bridge, but it could also be accelerating, or it could be slowing down. In those two situations, the force is not only acting towards the centre, but there'd be another force speeding it up or slowing it down. Okay? I'm assuming that they intended to mean a constant 15, even though they didn't say it. So there's a force just directed towards the centre of the circle, which would be kind of somewhere deep in the ground here. This is a bridge of a curvature radius 80 meters. Okay, but that's not the only force, of course. Wait, did they want all the forces or the total force?
This is the show the resultant force on the car.
Resultant force meaning the final force, which is what is shown here. Okay. Right.
Usually we use that as weight. Why are we using that?
Well, yeah, we'll see about what the F is exactly in a moment, because I'm sure they'll probably ask us something about it. What's the next part?
What is the magnitude of the resultant force?
So that F will be ma, which will be mv squared over r, which would be 1,225 over 80. Cancel a 0. What's that? About 2,300 or something. Oh, I was way off.
2,850.
Okay, what's the next part?
Show that the total reaction force from
There we go,
the
okay.
load on the car is approximately 7,000 newtons.
So, if you look at the car here, how many forces are acting on it?
3.
What's the 3?
The resultant, the drag, and the push.
Oh, yeah. Yeah, not quite. I know. There's no drag. There's no drag here. So, what are the forces?
Weight.
Well, weight is one force. And the reaction. Now, we won't consider the engine force because...
But why do we say this one is the reaction?
One sec. We won't consider the engine force. We'll just say the engine is doing enough to cancel the drag and ignore the 2. Okay. Now, reaction is always up from the ground. Okay, because the ground provides a reaction force. Okay. In response to what? In response to the weight. Now, which is bigger here, the reaction or the weight? Yeah, now this is interesting. They're usually equal. Like this cup of coffee here has a weight and a reaction which are equal, usually. But not so in this question. Why is the weight bigger? Yeah? Hang on, maybe Ming might know. Yeah? Go on, say it. Oh, say it again. Ming is going to tell me what it is called. Oh, come on, Ming, you can do it. What's the name? Well, you know what this is. I know you know. Ming wants to practice. Did you find it? Centripetal force, or also centripetal force. Yeah, you can say it both ways. So you're right. As Ming was saying, there needs to be a centripetal force here, which means the W needs to be bigger than the R. The W will be bigger than the R. And the difference, how much bigger it is what the F is. In other words, I'm saying F is the W minus the R. Now this can be a little confusing because usually the R is equal to W, but that's when the object's not moving. Here it's moving in a circle. And we learned that if it's moving in a circle, it has a centripetal force. Yeah. Now we know the F. We can know the W, and so we can know the R. The R will be F minus W, which is...
1,000.
Yeah. Oh no, sorry, I got that wrong, didn't I? R is W minus F. Yeah. 9810, is it? Minus 2810 is... Oh yeah, of course. What am I saying? 7,000 even.
So in circular motion, the resultant is down.
Yeah. Yeah. So this is actually, I want to do a small little example after this. Yeah. No, the resultant is towards the center. Yeah. In this case, that's down. Yeah. Okay, can I continue? So, who was asking for 12? Were you, a few of you? Yeah. What's so crazy about 12?
It's actually like one of the examples you give.
Is it the plain one?
Plain, yeah.
So what's wrong with it? Is it any way different to my example?
It just says from the equation in I, that's after you resolve it, that's L sine theta and L
Yeah.
cos theta, show that tan theta is equals to V square.
Yeah, I did that yesterday. When you remember me solving it, how did I get the tan theta? So I divided the two equations, didn't I? I got L sine over L cos, which became tan. And I think I said tan theta equals V squared over. So, I don't know, this seems like the exact same question as yesterday. I mean, if you look at my solution yesterday, I mean, the numbers could even be the same. What's the information in the question? Is it in a radius? Is it the radius a kilometer?
They didn't actually give any figures. They just wanted you to.
Ah, okay. So all you have to do is just call the radius something like r, and call the mass something like m, and just do it exactly like yesterday. That's all. There's no difference. Yeah. Oh, they are different numbers.
Yeah.
Okay. Well then, I will keep them if they're different numbers. Yeah. Now, before we go on, I just want to show you an interesting little example here. Can I scroll down? So, if we look at something on the surface of the Earth, we say the weight equals the reaction. Okay? But in real life, that's not 100% true. So let's take an example here. Here you are standing on the surface of the Earth, and you think, I have a weight, I have a reaction, and they're equal. Okay, so we're like, oh, it's not moving, its weight equals reaction. But it is moving. It's actually moving in a circle, isn't it? Just very slowly, you know. What's the periodic time?
1 day.
Yep, 1 day. That's a slow moving circle. Okay, so let's see what the R and the W really are. Okay, let's say, which is bigger, W or R? W. So F will equal W minus R. And what's F? MA. And what's A? V squared over the radius equals W minus R. Okay. So the W we know, that's mg minus R. So the R will equal mg, which is the weight, minus mv squared over R. So the R is not quite the weight. You have to take a little bit away from it. The V, what did we say the V was? Omega R, isn't it? So this will be W minus m, that's R squared over R, isn't it? Yeah, so omega squared R, and R is 2 pi over T. So will your reaction equal the weight? No, it'll be less. How much less? This much less. So let's take an example. Let's say we'll keep the numbers easy. We have a 100 kg person, and its reaction will not equal the weight, which is 100 g. It should be a little bit less than this, because it's moving in a circle. Let's calculate how much. So if we take out the calculators, It's 981 minus 100. 2 pi. And Marwan, on your phone, can you type in the radius of the Earth? I think it's about 6,000. Is it? Or is that the circumference? Just type in radius of the Earth. We'll type that in.
Isn't 2 pi over the square?
Oh, sorry, I looked at the square, didn't I? Thank you. This is 3,600. Why are you late?
Because my new card finished on my second boss.
Okay, well, you're coming back to the next class. Look at the time. It's 9:21.
Just 1 minute.
No, it's 6 minutes.
So my job.
Yeah. You're not helping this case. Come back at 9:50. Thank you. 3600 times 24. And what's the radius, Marwan?
6.371 kilometers.
No, it's like 6,331.
He's going to give you
It's
the
comma.
6,371 kilometers.
Yeah.
Okay, so type this in now. See what we get.
977.6.
Oh, that's more different than I thought. 977.
77.6.
So 978 newtons. That's quite interesting. That's quite interesting. So if you have a person standing on the surface of the Earth, they have a weight of 981 newtons, but a reaction of 978 newtons. And they don't fall to the ground. That difference is because they're moving in a circle. Okay, so I just think that's interesting. That in real life it's not really equal, because we have to remember we're all in circular motion at the moment. Yeah. You don't need to write this down. Oh, actually, do you know what? Well, no, you don't need to write it down, but it is something I remember seeing in the exam a long time ago. But it wasn't a question where they asked you to do a calculation. It was a concept question. They asked you, if an object on the surface of the Earth, if an object's placed on the surface of the Earth, will its weight or its reaction be greater, smaller, or equal? You know, so it was a question for like 1 mark. And the correct answer is obviously its weight will be greater than its reaction. Okay, so I don't need you to write this example down, but you should at least make some note or some picture to remind you that the weight will be bigger than the reaction on the surface of the Earth. Okay. Continue? Can I close this now? Yep. Okay, let's go on to the next lesson.